All right, it's all yours.
Awesome. Thanks, Pranav. Let me go ahead and share my screen. Awesome. Okay. Hey, everyone. My name is Vignav Ramesh, and today I'll be giving a lecture on how to
Vignav,
deploy.
I can't hear you. Never mind. I think I'm.
Can you hear me now? Great. Hey, everyone. My name is Vignav Ramesh, and today I'll be giving a lecture on how to deploy your pre-trained AI models. So after today's lecture, you all will be able to package and deploy your own pre-trained models. More specifically, we'll be going over 3 deployment techniques: pushing models to Hugging Face, turning models into web services or APIs with Flask, and deploying models via Docker containers. And as always, when we discuss more than one technique to perform a certain task, we have to discuss how to choose between those different techniques. So we'll end today's lecture with a quick discussion on how to decide which kind of resource you should use to deploy different kinds of AI model. So today we'll be doing a lot of live coding. So to make the most of the material, I'd recommend you guys opening a fresh Google Colab notebook to follow along. But if you'd like, you can always go straight to this master notebook with all the code already in it, which is available at this link, tinyurl.com/deployAImodel. All right, so here's the agenda for today's lecture. We'll start off with the what and why of deploying models, namely what deployment means, some motivating examples, a breakdown of the AI pipeline, and the necessity of model deployment. Afterwards, we'll move on to the how of deployment, which is all live coding. We'll implement a pre-trained model and then practice pushing it to Hugging Face, turning it into a Flask app, and packaging it into a Docker container. And finally, we'll end with a discussion of which deployment strategy to use in different scenarios. So now we can dig into what deployment really means. The best way to begin our discussion is probably with some motivating examples. So here's the first one. Suppose you have fine-tuned a machine learning model and want to make it accessible to other researchers. Ideally, you would want the code and the weights to be publicly available so that others can load the model, run inference, and also fine-tune it further for additional downstream tasks. How would you go about releasing your model? And here's our second motivating example. Suppose you fine-tuned a contrast of language image pre-training or a CLIP model for image caption classification, that is, predicting which of several captions best matches a user-provided image. You want to turn that model into a publicly available service where users can upload images for automatic classification. What tool would you use? So we'll discuss both of these examples later on in the lecture and their solutions. But first, we should go over what is deployment. Put simply, deployment is the method by which you integrate a machine learning model into an existing production environment, whether it be as a public web service, a commercialized API, or a tool for use by other researchers. Packaging and releasing a trained AI/ML model is one of the most important steps in the machine learning pipeline, and it can be often one of the most cumbersome. The generalized process of developing a machine learning model consists of 3 steps: training, deployment, and inference. The order of these operations makes it clear that effective, large-scale, and accelerated inference can only occur post-model deployment. That means it's necessary for models to be effectively deployed for easy access by end users who are looking to perform inference with their own data. So now recall motivating example number 1, where you fine-tuned a machine learning model and you want to make it accessible to other researchers. You want the code and the weights to be publicly available for loading, inference, and fine-tuning. So how'd you go about releasing your model? Here, the basic or vanilla approach would be to release the code for generating your model along with a pre-trained checkpoint on a site like GitHub. But this raises a couple of issues. First is that of technological literacy. You may want your models to be accessible for inference by end users who have little experience with programming, let alone reproducing ML code and accessing or loading custom model checkpoints. Or you may have tech-savvy users who don't want to re-implement the model. They simply want to run inference without having to define the model structure. Or finally, the end users may want the entire model to be run in a non-programmatic format. For instance, they may want images to be uploaded on a website rather than loaded in through Python's Pillow library, or text to be inputted through a form rather than terminal. All of these issues make it of utmost importance to deploy your model in a manner that befits the wants and needs of your end users. So this leads us to the next item on our agenda, the hows of model deployment. And before we can begin discussing deployment strategies, we actually have to programmatically set up our pre-trained model, the model we're actually going to deploy. So we're going to implement a clip model and test it on the task of image caption classification, just like motivating example number 2. First, let's go ahead and open up a new Colab notebook and get our environment set up. All right, so the first thing we want to do is install the needed libraries and go ahead and run our imports. They'll be importing the pillow library and requests. All right, so now we can use the transformers library that we downloaded to load in the classes that we're going to use for our clip model. All right, so the next step is to load in our pre-trained model. And we're going to be using OpenAI's clip-vit base patch 32 checkpoint like this. So model equals clip model dot from pre-trained OpenAI / clip-vit base patch 32. And we have to do the same thing for the processor. Processor equals clip processor from pre-trained. All right, so this is a bit of circular reasoning since we're downloading the model from Hugging Face, which is one of our deployment strategies. But the key idea is to imagine that we're getting these model and processor variables from actually constructing and training your own clip model. So when you're actually deploying your own AI models, replace all of this code that we've written so far with the code to generate and train your own clip model. And you'll have these two variables, but not from Hugging Face. All right, so now that we've downloaded the models, let's do a quick example of inference. So I guess what we can do is train our model on an image of a dog and have it predict whether that image is of a cat or a dog, and choose the right caption for that image. Let's go ahead and look up the image of a dog. Let me go ahead and this one. Copy image address. Okay. So now we can load in the image like this. URL equals, and set the URL to the image. Might not be. Let me. Yeah, that's the link. Not sure what I copied before. There we go. Okay, so now we can open up the image as an image pillow image object. All right, so now we can process the input and we can use the captions, a photo of a cat and a photo of a dog for the model to choose between. Now we have to pass the text and the image to a processor. All right, so now we can run the inputs through the model like this. Output equals model. So next, we can get the image text similarity score for each caption. And then finally, we have to take the softmax of logits per image to get the label probabilities. And we can go ahead and print the probabilities out. All right, so here's our output. And this indicates that the image is indeed of a dog because the model chooses the second caption, a photo of a dog, with a probability of 0.9983, so a huge margin. So we've now successfully set up our pre-trained model and we can move on to deployment. So up first, we have pushing to Hugging Face. So Hugging Face is an online data science platform that provides tools enabling users to build, train, and deploy ML models based on open source code. So put simply, it's like the GitHub of pre-trained model checkpoints. Users can publish custom AI models that any Hugging Face user can then load and call in their own software programs. So the first thing you need to do is set up a Hugging Face account at huggingface.co. So once you go to huggingface.co, it should prompt you to sign up, but as you can see, I'm already logged into my account. And your username is actually all you need to push a model to Hugging Face, besides, of course, a model. Now moving back to Colab, we can start once again with environment setup. Now, the first thing we want to do is install libraries again. We need the Git LFS library. And now we can actually import Hugging Face. So from Hugging Face, import notebook login. And we're running notebook login. So this will link our Colab notebook to Hugging Face. So as you can see here, the notebook login command prompts you to input a Hugging Face token to verify your account. So you want to go to huggingface.co/settings/tokens, or you can also just click on this link. You want to create a new token. Give it a name, so deployment demo. Make sure you change it to a write token because that's how you can actually push to the Hugging Face hub and generate. Now go ahead and copy it. We can go back and enter it here. So now we've successfully logged into Hugging Face. Now all we have to do is push our model and processor variables to Hugging Face with this code. Name. So right now we're going to set the model name, so the name we actually want our model to be under on the Hugging Face hub. So why don't we call it clip bit base 32 demo. Now all we have to do is push the processor and model to the hub. So processor.push to hub, repo path name, model name. And we have to set a commit message, which just outlines what you're doing. So we'll call it add processor and use temperature equals true. So it just won't say the directory it's temporarily using to upload the files. And now we want to do the same thing for the model. So model.push to hub, repo path or name equals model name, commit message equals add model, and use temperature equals true. And that should be it. Now we just have to run this. All right. So right now it's downloading the model bin files and it'll go ahead and push them. So this will take a bit of time. We do have to wait for a few minutes while this process completes. So in the meantime, I thought I might as well show you guys what the Hugging Face inference API looks like for a different model. And then we can also, I'll also be talking about this at the very end of the lecture. So this model is called GPT-Neo. It's basically a open source, no cost spinoff of GPT-3, which is OpenAI's autoregressive language model that uses deep learning to produce human-like text. I'm sure many of you have heard of it. Unfortunately, we can't test out this inference API, which is hosted on the Hugging Face site for Clip because it requires multiple inputs and they have to pass through a processor variable like we saw here. We have to take the text and image and we actually have to pass it through the processor. But GPT-3 is a really good example of using this inference API because all we need is to input the start of our text and we'll be able to test out the text completion feature, which means it'll continue generating text to add on to what we've included here. So as an example, let's look at the examples they provided. Example 1. So this is the example they've given. And once you run compute, it'll load the model and then show the model's output right here in the inference API. So it's really easy to test models with this inference API. And it's the best sort of use case for this is to test single examples and see how the model performs. But actually, another really neat tool that Hugging Face provides is what they call, under this deploy button, the accelerated inference. And what this does is this actually sets up an API with an API URL. You just have to get authorization through Hugging Face. Then you can send large input queries to the API, and it will automatically run the model on all the inputs you send and give you an output. So it makes the entire inference process really easy, which is really useful. All right, let's go back and see if it is completed. So the model is still loading here. In the meantime. how this is going. Okay, so 63%. Yeah, so as you can see, we can get GPT Neo's output right here in the hosted inference API. So it's a really nice way to test out a model on a few sort of example tasks to see how it's performing. And this also is available at the public link. So anyone can go to huggingface.co/eluther.ai/GPT-neo 1.3b and test this out with their own prompts. So perhaps the best use of the inference API is when you're using a model that you yourself didn't create, that you've just looked at Hugging Face, and you want to see what it does, how it performs online really quickly before you actually download it and run it programmatically. All right, so that's all I wanted to really go over in this time. So now let's just wait for a bit while the model and processor finish uploading. Okay, just around 1 minute left. And also, if you notice here in the output, as soon as you push the model and processor to Hugging Face, it creates a new repository on Hugging Face at this link. So huggingface.co/your username/the name of your model. So this is actually the exact site where your model will be hosted later on. So as you can see, it's already created the site online, and it has its own inference API already set up here. So like I said, unfortunately, it doesn't work too well for Clip because of the because it has multiple inputs and they all have to be passed through the processor variable. But for other models, it's really useful to have this link available online for quick use to test out the inference API and so on. Okay, perfect. So it has finished pushing the processor and it's now pushing the model. Okay, while we wait for it to do that, why don't we go ahead and start discussing how to perform inference with Hugging Face. So this is the real magic of using Hugging Face. To run inference, all we have to do is load and run our pre-trained model just like this. So we create a processor variable again. Let's clip processor dot from pre-trained. And we're going to give the name of our model. So in this case, your username /clip vit base patch 32 demo. And once again, same thing for the model. Model equals clip model dot from pre-trained, and then the same model name. And then the really neat part is once you load in the processor and the model, you can use the exact same inference script that you used before when you had the model and processor variables from actually creating your own AI model. So let me go ahead and combine these into a single cell. And we can literally copy and paste this exact inference script down here once we have the new processor and model variables and run this to get the probabilities for this image and these captions. And let's just wait for this to finish while the model uploads. All right, so this should be the last thing it has to do to push the files, which is cleaning the bin file after it uploads it. Just around a minute left, and then we should be good. Right, so this should be done. Awesome. So we've now successfully pushed to Hugging Face. And as you can see, once it's pushed to Hugging Face, all you have to use, just to recap, is your username and model name, and you put that into the from pre-trained function that goes into clip processor and clip model, and you can automatically download the processor and model that you just pushed. So we can go ahead and visit the site again. And as you can see here, actually, if you click in the use in transformers, it actually gives you the exact code you need to download and to load in and use the processor and model from Hugging Face. And the neat thing that the transformers library provides actually is we don't necessarily have to use clip processor and clip model. We can use the auto processor and auto model classes that transformer provides, and it'll automatically figure out which class is best to load in your pre-trained model. So we can just replace this with this, and we should be good to go. And as you can see, using the exact same inference script we used for the custom model and processor itself, it gives us the correct output. So yeah, that's it. You now know how to push models to Hugging Face and how to use models already on the platform, which is just by changing this name and yeah, the username and model name right here to download whichever model you want off of Hugging Face. Awesome. Okay, so let's now move on to our next deployment strategy, which is creating web APIs with Flask. So Flask is a micro web framework written in Python. Simply put, it's a Python module allowing for streamlined development of web applications. This means that it provides programmatic support for web-related tasks, including displaying pages, routing, request handling, and more. It's essentially an easy-to-use deployment method specifically for Python-based AI applications. And some alternatives to Flask include Django, Tornado, Bottle, React, and Web2Py. Okay, so now let's get started with building a Flask server to deploy our clip model. And unfortunately, we can't use Colab for this task because it has a setting called auto reloader that prevents us from actually running the server on Colab. So right now, let me give you around 30 seconds to open up the code editor of your choice. And I'll be using Visual Studio Code. All right, so the next thing you want to do is go to terminal and create a folder called Flask and cd into it just to store all the files we'll be needing. Flask. All right. So now what we want to do is create a file called runserver.py to set up our server. So I'll go ahead and open this up in Visual Studio Code. Okay, so our first file is run_server.py. And this will be the file where we set up our Flask server and actually run it on a local port. So we can start by importing our required packages. Correct. So first URL for template hash request. Oh, whoops, we already request. PIL image import requests. from transformers import the processor model, import OS. All right, so the next step is to create our app variable in Flask. So this app variable will store our entire Flask app. So next, we want to define a function that actually runs our clip model so that we can use it in later functions of our Flask app. So this function should take in an image and a list of text captions and return a list of probabilities corresponding to the caption list, just like we saw with in Colab with pushing talking face. We call this predict with arguments, image text. The model equals clip model from pre-trained. So once again, loading in our model. And here is where you would replace this code to load in the models with your own code to create, with your own code to construct the clip model. And you wouldn't actually put the training code here, but you would train it, store your pre-trained checkpoint somewhere in this Flask folder. And then here you would write code to load in the model from that pre-trained checkpoint. So clip model from pre-trained. And once again, same thing for processor. Processor equals the processor from pre-trained. Okay, so inputs equals processor. So running the text and image through the processor. Text equals text, and images equals images equals image. Return tensors equals pt, and padding equals true. So now running the inputs through the model, outputs equals model inputs. Okay, so logits per image equals outputs dot logits per image equals logits per image soft max equals 1. Now we want to print out the probabilities, and this will be seen in the terminal where we run our server, but we also want to return it from the function. So we can sort of make it look a bit nicer by putting just the probabilities in brackets instead of outputting the entire tensor. So bracket plus string probs 0 of 0. So prob 0 is what stores our two probability values. And that's it. So we've now created our function to run our model on a given image and list of captions. So our next step is to create a simple HTML page to ask the user for an image upload. And we want to store this in a file called uploadimage.html and put that in a folder called templates, because Flask's render template functionality looks for templates in the accompanying templates folder. So let's go ahead and create a new folder called templates. And inside that, a new file, upload_image.html. Okay. So here, let's go ahead and set up a pretty trivial HTML file that just takes in a user image upload. Type HTML, setting the language. Head tag. And setting the title for our page, so we can call it upload image. Now, exiting out of head, let's go to body. Let's create a container. Inside that, let's set this up within a row. And our corresponding column. So this all this code isn't actually necessary for functionality. It's just to make the location of the objects on the image look nice and clean. All right, so once we're in our container in the column variable, column tag, we want to sort of display a header. So upload image. And just to make it look nice, we can add a new line. So now here's the actual functionality. Now we want to create a form for users to upload an image. So form action equals upload image, method equals post, code type multi-part form. Inside here, we want to create a form group. And we want users to be able to upload a custom file. And in that, we finally have our input variable. So input type equals file, class equals custom file input, name. This name can be whatever you want, but we can call it image, and we have to give it a corresponding ID. So we'll call that image as well. Right. So yeah, we now have our HTML file. And so one other thing we have to do is before we end the form, we have to make sure that we include the actual button to upload the image. So we can do BR and set up our button. So button type equals submit, class equals button primary. And we want to call it upload. All right, so this should be all we need to create our HTML file that allows users to upload an image to a form. So we can now add a web route to our Flask app that displays this HTML page and processes the user inputted image. So go back to runserver.py, and we can add in our new app route. So app.route, and this can be whatever name you want, but why don't we call it upload image? And this will actually be the URL after the domain name, where users would actually upload the image. Then we want to specify the methods are get and post. And under that, we want to create our upload image function. So this just renders the HTML template. Okay. So now what we want to do is upload this modify this upload image function to save the image that the user uploads via the post method. So we have to add this code. If request.method equals post, if request.files, image equals request.files image. This is just grabbing the image that the user just uploaded. And next we want to save it. So image.save, os.path.join. We can save it to the images folder, which we'd have to create in a bit, and image.file. All right. And why don't we just create an empty images folder right now to store the images that users upload. Images. Okay, so now to run this image through our clip model, we have to make one last modification to the function. So after we save the image, we actually open it with the pillow library, so image.open, os.path.join, images, file name, setting our captions, a photo of a cat, and a photo of dog. And for time's sake, I'm sort of programming the captions in here and just letting users upload the image, but it would be really easy to modify this file to have users input the text captions and the image in a form. But just for sake of time, just uploading an image is a bit quicker. So now, once we have our captions, we have to re-return render template with our updated variable. So upload image.html, uploaded image equals image.filename, var equals predict args, image text. And as you can see, here's where we're calling our predict args function. All right, so if you notice, we just included a new return statement that re-renders the HTML template, but it passes in additional variables, uploaded image and var. And yeah, so the reason we did that is because that's how we're going to load in our new image and the output of predict args into our HTML file to display that for the user. So let's go ahead and return to our HTML template to put those variables in the new return statement to use. Let me just make sure this is okay, perfect. Oh, oops. There we go. That was a mistake. All right. So now going back to upload image.html, right before the ending body tag, we want to include these two tags. So first, image source equals open two brackets URL for send loaded file name equals uploaded image. Height, and let's just set the height so that it doesn't look too big. And one more time. Okay, so as you can see here, this will display the image that the user uploaded as well as the probabilities outputted by the clip model. And these opening and closing double brackets used here are the Flask shortcut for loading variable values into HTML pages. So we're almost good to go, but one last question remains, which is what is the send uploaded file function that we're using to get the source of the image? And we would have to define that back in runserver.py. So let's go ahead and do that. So one last app route. File name. Let's call this send uploaded file, just like the function we include in the HTML page. That takes in a file name. And from Flask, import send from directory. So making sure we have our sender from directory import. And whoops, not sure why. Okay, get rid of that. And we want to return send from directory images on it. And that just basically sends the path to the image that the user uploaded to our HTML page. All right, so we've just finished coding the functionality of our Flask app. All that's left is to start it. So if name equals name, app.run. So here you want to set the host domain. I'm setting it to just 0.0.0.0. Then choose a port. So any port in the 5000s range should be safe, but I'll go ahead and do port 5003. Debug equals true. All right, save the file and that's it. Now we can run the file in terminal to start our app. So Python run server.py. Okay, so as you can see, it starts the Flask server, and all we have to do is now test it out on port 5003. So we can follow this link, and this will say not found, so make sure you go to the upload image directory. As you can see, we now have our upload image page, and we can upload files. So let's go ahead and choose a file in downloads. Yep, dog.jpg, our same dog image. You can upload that and press upload. And it'll take a while to run the model, but after that, we can see also the output in terminal if it's outputting something right now. Yep, as you can see, it prints out the tensor programmatically, and it outputs all the image and the tensor right here. All right, so that's all we need to know for Flask. Now we can move on to our final deployment strategy, which is deploying to Docker. So what is Docker? Docker is what we call a platform as a service product. It uses OS level virtualization to deliver software and packages called containers. This allows developers to easily reproduce the working environment that is used to train and run their ML models anywhere. Docker allows developers to package code and dependencies into containers that can be ported to different servers, even on different hardware and operating systems. For instance, a model can be developed on a local machine and then easily ported to external clusters with additional resources, such as GPUs, more memory, or more powerful CPUs. So Docker is overall a really useful tool for packaging models into containers that can be ported anywhere. Before we get to the code, we have to define a few terms. So first, a Docker image is an ordered collection of root file system changes and the corresponding execution parameters for use within a container runtime. So simply put, an image is a Docker object that specifies the environment in which certain files can be utilized and commands can be run. A container is a runtime instance of a Docker image. A Docker container consists of a Docker image, an execution environment, and a standard set of instructions. And finally, a Docker file is a text document that contains all the commands you would normally execute manually in order to build a Docker image. Docker can build images automatically by reading the instructions from this Docker file. So now, on to deploying our model with Docker. Once again, we unfortunately can't use Colab because of its configurations. So let's head back to terminal. We can end our server. And let's go ahead and create a new folder called Docker to store our files. And then we have to create a file called main.py that contains the code for initializing and running our clip model. Let me cd out of this. I'll create a new folder called Docker. Cd into that and open that up. Let's get rid of my current VS code. Code this. Okay, so this opens VS Code with the Docker folder. All right, so now we have to create our file main.py to initialize and run our clip model. So this is once again a repeat of code that we discussed earlier in the lecture, which is just downloading and running our model. And once again, here's a file where you would replace the code to load in our model and processor variables with your code to actually load your own model and processor from your own pre-trained checkpoint that you constructed yourself. So let me go and code this really quickly. It's just sort of a repeat of what we've already discussed. Port requests. And the one new thing is that we have to import argparse because we're going to be asking for user arguments with Docker. So put model.from pre-train. Now we can get our output given a URL and a list of captions. And because we're asking, because we'll be running the Docker commands in terminal, where we can't actually input a list, we should ask for a comma separated string of captions. So image equals image.open requests.get URL inputs equals processor text equals. So we're taking the text variable and splitting it by comma. So that's why it's really useful to ask for a comma separated string, because all we need is one string variable and we can convert that into a list really easily. Images equals image, return tensors. And padding equals true. All right, so now we have to run our inputs through the model. Get the image text similarity scores once again. And print the probabilities. All right, so now we can create our parser. So our parse.argument parser description run the model. So this is just telling the users what the argument parser is for. Now we have to add our arguments. So we have two arguments, URL and text. So URL type equals string, and the description in the help parameter is URL of image. And now we want to do the same thing, but for the text. So parser.add argument text, and we want, it's also a string, and we want users to upload a comma separated sort of list of captions. All right, now we have to parse the arguments. And that's it. Now, when we go to, when we actually call main.py, we want it to run get output with URL and parse.text. Okay, perfect. So just to recap, this code is almost all repeated from earlier section of the lecture. It's just that we've added in parsing arguments from the command line. Okay, so now onto the new stuff, which is creating our Docker file. This would just be in a new file called Docker file. So the first line is going to set our build stage, which in our case constitutes the programming language we will use and its version. So we call this, we use the from command from Python, and then after a colon specify a version. So we can say 3. Next, we have to add the files needed in our container. So add main.py. Afterwards, we use the run command to set up our environment by installing the packages that we need. So run apt-get update y. Yeah, install. So this is just needed to run the Docker container. It's actually not needed for, it's not needed for main.py. And finally, the command that we do need for main.py, run pip install all our dependencies. So transformers, pillow, requests, argparse, torch vision. And probably a better way to use this command would be to run pip install -r requirements.txt and put all the libraries you need in a requirements.txt file. But just for sake of time, I'm doing this because it's a bit quicker. All right, the last line of our Docker file is setting up our entry point. which is essentially the beginning of every command that we're going to be running through the Docker container. Since we're only going to be running main.py, which is a Python file, we can set our entry point as Python. So entry point. And that's it. Now, the next thing we have to do is make sure that we have Docker installed. So going back to Google, you can go to docs.docker.com/get Docker. So this is Docker's documentation pages, and the get Docker page gives you really easy to use instructions for installing Docker on whichever device you have. So I use Docker Desktop for Mac, and I already have Docker installed. But here's where you would want to install Docker on your own machine. So I'll give you around 30 seconds to do that if you're following along, just so that you can run the commands we use after setting up our Docker container. All right, so hopefully you're able to start downloading Docker. And while that's going, we also need to create an account on Docker Hub, which is basically like the GitHub for Docker containers. And as you can see, I'm already signed in. But what you would want to do is go to hub.docker.com and create your own account with your own username. All right, so once you do that, we're now ready to start creating our Docker image. So to build our Docker image, all we have to use is the build command. So Docker build, and then we have to give it a name. So your username / the name of the Docker image. So I'll call it clip demo. And then finally, we have to give it a tag that specifies its version. So colon, whatever version it is. So we can call it a v1. And finally dot. So this just indicates that the folder within that the Docker file is contained in is the current folder. Right, so now it will actually, as you can see with the log, it's actually running the commands in the Docker file that you can, and you can see the exact output, which is really convenient. So as you can see, it finished steps 1 through 4 and is now running step 5, which is the pip, installing packages. Right, so we do have to wait for this to finish. So unfortunately, a lot of waiting in this lecture because we need the models to actually be pushed and to be created for us to use them. Hopefully this finishes up pretty quickly. Okay, we're almost there, just on Torch and Torch Vision. Yeah. And in the meantime, while we're waiting, if you guys still have to create a Docker Hub account, go ahead and do that. If you're running this along with me, I'm sure you already have Docker installed, but if you don't have Docker installed yet, wait for that to finish. And all you have to do is run this command, docker build -t, your username / clip demo, and then give it a tag. Awesome, so it's finished installing dependencies. Perfect, so we just finished building our Docker container. Now, we can check that an image was created with Docker images. So as you can see, we've created our Vignav /clip-demo with our tag v1. Okay, so now we can actually run the clip demo container by passing in arguments to main.py. And we can use that to run the clip model. So Docker run /clip demo v1 main.py. So remember, the entry point was Python. So it's as if we were running the Python command right here before passing in our arguments. So our first argument would be main.py because we want the main.py file to be run. Next, we want to upload the URL of our image. So we can go back to image of a dog, get that URL, or why don't we go back here? Grab the URL from here. back to terminal. So our next argument has the URL of the image. And finally, our last argument is the comma separated list of captions. So we can call it a photo of a, why don't we switch it up and say a photo of a dog and a photo of a cat. We can switch up the order. Yeah, and we can go ahead and run this. As you can see, it goes straight to the main.py file, and it's already downloading our models from OpenAI. And this would actually be the step where it downloads a model from OpenAI. That would be what you replace with your own code to load in a model checkpoint that you've custom trained. Let's go ahead and wait for inference to happen. All right, so as you can see, our same output but flipped because we changed the order of the captions. It correctly loads in the image, the captions, and gives us our output through the Docker container. So the next thing we want to do, so right now our Docker image is stored locally on our own terminal. The next thing we have to do is actually make sure that we can push it to Docker Hub, where it can be used by any Docker user, and it'll be available publicly. So you want to go back to Docker Hub, create a new repository, give it the same name that you named your image. So this is really important. If you don't give it the same name, it's still possible, but it's much harder to push the image to it. So let's call it clip demo. Make sure it's public, and we can create it. All right, so we now have, you now should have your own Docker Hub repository. Now what we want to do is go back to our Docker folder, and I've already run this step, so I'm not going to run it, but make sure that you log into Docker from terminal. So the command is docker login dash u, your username. So you want to put that there, and then dash p for password, your password. And then docker.io. So docker login dash u, my username, dash p, my password, docker.io. And that's the command you want to run to log into Docker. So I'll give you guys maybe 10 seconds to run that command for yourself. I'll leave it up here for now, but I'm not going to actually run this because I'm already logged in. All right, so I'll let you guys run that. After that, all we have to do is push it to the repository that we've just created on Docker Hub. So it's as simple as docker push and the same name and tag. All right, so this, so 2.6 gigs. So this will take a while. So I guess while we're waiting for this to be pushed to Docker Hub, what we can do is move on to our last section, which is a discussion of which of our 3 deployment techniques we can use in different scenarios. All right, so here's a little Venn diagram to help us. So as you can see, Hugging Face is sort of the gold standard of deployment. It's a tool that the majority of AI developers use to release their models, hence why we use it to actually download the OpenAI version of the CLIP model. And the fact that it's well known is a really big reason to use it, because your end users, there's a high chance that your tech savvy end users will be familiar with it. And it also has that neat tool that we took a look at earlier called the Accelerated Inference API, which simplifies the entire inference process for end users. And both Hugging Face and Docker, as you can tell with the push commands, have Git-like version control, which is really helpful when making updates. Docker in particular allows more flexibility in terms of reproducing the exact working environment, as you could tell with the command to install dependencies in the Docker file. And it employs virtualization while Hugging Face doesn't. Finally, Flask has a much better user experience, especially for non-tech savvy users, than either of the other two. You can turn inference into a web service, as we saw with creating our HTML page, and allow for non-programmatic input, like the image upload that we coded into our HTML file. However, Flask still does allow for programmatic user input, as with Hugging Face and Docker. So all 3 of them are really good options for users who are familiar with the command line and with programmatic input. So yeah, that's just a quick overview of how to choose between Hugging Face, Flask, and Docker. And now let's go back and see it says pushed. So we're just waiting for this to push, and then we'll go ahead and run our command to actually create to actually call this container from Docker Hub and use it to run the clip model. Yep, and I guess in the meantime, I'll just go over a quick note for those of you who are following along. If you do go to tinyurl.com/deploy AI model, you should see all the code to run Hugging Face, as well as links to the code to set up the server for Flask and the code to set up the Docker file in main.py and the commands that you would have to run. Okay. Yeah, I guess we're running out of time, so this might finish by 7:45, but worst case if it doesn't, the command you have to run after pushing to Hugging Face, after pushing to Docker, it's actually really nice. It's the exact same command you would run with a local image. All you have to run is Docker run your username / the name of the Docker container on Docker Hub, then the tag main.py, your URL, and your comma separated string containing captions. And that's it. All the commands are available here as well. And I guess, yeah, for now, I don't think, as you said, this will finish running in time, unfortunately. So as long as you let this finish running and then run the same exact command, you all should be good to go in terms of using Docker containers.
Awesome, Vignav, this was a wonderful lecture. Thank you so much for sharing these insights on how to deploy your model.
Of course.